Hi everyone. In this video, what we will see is we will see something called convolution theorem and partial identity for Fourier transformation. Okay, fine. So, what is the convolution theorem? As we have discussed in the Laplace transformation, it's exactly similar to that. So, convolution theorem. Suppose if you know Fourier transformation of f, you can denote it by f of s, and if you also know Fourier transformation of g, which is denoted by g of s, then what if you want Fourier transformation of the convolution of f of s? Convolution of f and g. Fourier transformation of convolution of f and g. Then this is nothing but Fourier transformation of f times Fourier transformation of g. Okay, that's it. Now we usually denote this as the product of f of s into g of s, right? Because Fourier transformation of f is defined as this. Now, one thing I haven't defined is what is the condition here. So where f star g, I should define it as f of x star g of x is defined as, that's what is called as convolution, right? So f of x star g of x is actually defined as 1 divided by square root of 2 pi into integral minus infinity to plus infinity f of t into g of x minus t into dt. Okay, yeah, that's it. So that's a convolution product, or in other words, that's the all-term product of functions f and g. And if you want to find out the Fourier transformation of this all-term product or the convolution product, then this is there. Now we'll also see Parseval's identity quickly, then later we'll solve the problems. This Parseval's identity. Some people call this as Parseval formula, some people call this as Parseval theorem. It's okay, all of them is. Now what I wanted was, suppose if you know the f of x has a Fourier transformation, let's say suppose f of x Fourier transformation is f of s, then integral minus infinity to infinity mod f of x whole square dx is equal to integral minus infinity to infinity mod f of s whole square dx. Nice result. Now the Parseval identity can be written for Fourier sine and cosine transform as well. Obviously, you can, right? You can just replace all of them with Fourier sine transform, Fourier cosine transform. That's going to work very well. So there's no problem at all. And similarly, suppose if you want to, I'll write one more remark or property as well. If you want to find out the product of two functions and its integration, for example, if you want to find out what is 0 to infinity f of x into g of x, because of the convolution theorem and the property of Fourier cosine and transformation, this can be proved as this is 0 to infinity Fourier cosine transform of s into Fourier cosine transform of Fourier cosine transform of f and then Fourier cosine transform of g into ds. In fact, you can also prove that this is also same as that of Fourier sine transform of s and Fourier sine transform of g as well. Meaning, we can say that this is equal to integral 0 to infinity Fourier sine transform of f, which is fs of s, and Fourier sine transform of g, which is gss. So this is very important result, which is coming out of the convolution theorem. So now let's try to solve one problem based on Parseval identity and convolution theorem. Problem page. So find the Fourier transform of Fourier transform of f if f of x is equal to 1 minus mod x for mod x is less than 1 and 0 otherwise. And hence evaluate integral 0 to infinity, not evaluate probably, and hence show that integral 0 to infinity sine t divided by t whole to the power 4 into dt is equal to pi by 3. Right? Now, not proof, solution. Then only direction. Right? So let's solve the problem. Solution is simple. All that we wanted was Fourier transformation of f. So let's find f of s, which is 1 divided by square root 2 pi into integral minus infinity to infinity f of x into e to the power isx dx, isn't it? Now you see the function has been defined in two phases. One is mod x less than 1, the other one is 0. So how do we change this function? So first things first, let's write this is 1 divided by square root of 2 pi into integral minus 1 to plus 1. Remember, mod x less than 1 happens minus 1 to plus 1. Then mod x, 1 minus mod x times e to the power isx, which I can write it as cos sx plus I sin sx. Okay. So at single start, what I can do is you can think of the limit, which is minus 1 to plus 1, and this is an even function, and this is an even function. So the product will become an even function. And this is an odd function, therefore this product will become an odd function. So the integration over here is going to 0 because integral of minus 1 to plus 1, an odd function is going to be 0. Therefore the only thing which left is 1 divided by square root of 2 pi. Remember, this also I can write it as 2 times integral 0 to 1, 1 minus, remember in the 0 to 1 all the values are passed, so all the values are passed to means mod x is going to be the same value, therefore 1 minus x itself into cos sx into dx. So hopefully that simplification is easy. Now this is simple, right? So all that it requires is just use the Bernoulli's formula or integration by parts, whatever it is, and then find out the answer for this particular question. So what is the answer now? Square root of course it gets cancelled, so square root of 2 by pi into this one would be 1 minus x into the differentiation of this, which is sine sx divided by s, minus the cos x divided by s square, substitute the limit, and hence finally you will get this is equal to square root of 2 by pi into 2 sine square s by 2 divided by s square. Sorry. You know, this is the problem if you copy and paste. 1 minus cos s divided by s square. Okay, good. So that was the answer. So what I want to do was, I want to evaluate something, right? What I want to evaluate was, of course, if the question was simply find the Fourier transformation, the question ends over there. But I want to evaluate something which is purely in sine. So what I want to do was I want to change this answer purely in sine. So that's why I'm going to do it. So this one is 2 by pi into, what is my 1 minus cos s? 1 minus cos s is nothing but 1 minus, 2 sine square s by 2, right? So this is 2 sine square s by 2 divided by s square. That's it. Therefore, now this is actually fully of sine. So this is nothing but my Fourier transformation of f. So this is what I have. Now, to evaluate something that what I have written in the question, I'm going to use partial identity. So first of all, what is the partial identity here? So Parseval's identity is, we know that this is integral minus infinity to plus infinity. Modulus of the Fourier transformation square is same as that of the modulus of the, meaning integral minus infinity to plus infinity, modulus of the f squares dx as well. That means if you want to find out the integral of integral minus infinity plus infinity, what was the term that I have here? Square root of 2 pi, square root of 2 by pi into 2 sine square s by 2 divided by s squares modulus square into ds. That is equal to integral minus infinity plus infinity modulus of f square, which is modulus of 1 minus mod x whole square into dx. Okay, yeah. Now what is this now? So everything I can just modulus. So all of them are square terms, so modulus can be thrown off. You know, that's easy. And then you can retain only this sine square s by 2, which is sine to the power 4 s by 2 divided by s to the power 4 into ds. And remaining, probably I'll push it to the right side. Who is that? Is square root of 2 by pi, which will give you pi by 2, and here is 4. So this is pi by 4 into 2, which is 8. So pi by 8 times integral minus 1 to plus 1. Remember, integral minus infinity plus infinity can be boiled down to minus 1 to plus 1, because the definition says as long as mod x is less than 1, then only the value of the function is 1 by mod x square, otherwise it's going to be 0. So in fact, here itself I should have it. So here it's supposed to be minus 1 to plus 1. And this one is mod square, so therefore this is simply 1 minus x whole square, because it's an even function, so I can just replace this as 1 minus x square into whole square, and then I write this integration as 0 to 1 and multiply by 2. This adjustment is clear. Now purely an integration, this is pi by 4 into, what is the integral, 1 minus x whole square, which is 1 minus x whole cube divided by 3. Then all that you have to do is just substitute the limits. So that's going to give you 1 minus x whole cube divided by 3. The limit is 0 to, so it's upper limit is 0. The lower limit is minus 1 by 3. So this is minus 1 by 3. Okay, fine. So that is integral minus infinity plus infinity sine to the power 4 s by 2. But what I wanted was integral minus infinity plus infinity. What I wanted was integral 0 to infinity sine to the power 4t divided by t to the power 4, right? So what we will do is we'll try to substitute something. Let's say, let's keep this minus infinity plus infinity sine to the power 4 s by 2 divided by s by 4 into s, and let t is equal to s by 2. Obviously, it's obvious substitution here, because you see that I wanted sine to the power 4t. So let t is equal to s by 2, and hence this will give me 2t is equal to s. In other words, here I can replace it by 2t 4 to the power 4, and further it will give you 2 into dt is equal to ds as well. So which means ds can be replaced by 2 into dt. Therefore, and also limits. So limit also you have to check. So as s is equal to minus infinity, this gives you t also is minus infinity. As s equal to plus infinity, this gives you t also plus infinity. So therefore, this implies the complete integration can be written as integral again minus infinity to plus infinity, but this time this is sine to the power 4 t into sine to the power 4 divided by here s to the power 4, which is 2t power 4, right? So which is 2 power 4 into t to the power 4 into dt, not just dt, 2 dt, okay? 2 dt equal to pi by 4 into minus 1 by 3. That's it. Now everything is an even function here in the left side. Here you see this is an even, this is an even. So I can write this expression as 2 times integral 0 to infinity sine to the power 4t divided by t to the power 4. Remember here I have one more 2, so I can write that 2, and I can write this 2 to the power 4 as well, into dt is equal to pi by 4 into minus 1 by 3. So minus 1 divided by 4 by 3. Now you see you can cancel all of them, right? So 1 2 2 2's, and here one more 2, so this all of them together get cancelled, and therefore it gives me integral 0 to infinity sine to the power 4t divided by t to the power 4 dt is actually minus 5 by 3. Okay, yeah. Seems like I missed one minus in the computation. Not sure where did I miss that. Yeah, here. So you see in the integration part, it's not just 1, it's not but 3, it's supposed to be minus 3, right? So at this place 1 minus s whole cube divided by minus 3, which means there is one more minus missing over here, and hence this should be plus 1 by 3, and hence this is also plus. So this is plus, this is plus. So that's the answer. So what I have done here is we have just found out the Fourier transformation of whatever the function given over there in the question. Then we have used the Parseval identity to deduce this particular result. Okay, yeah. So there are a lot of such techniques are available in Fourier transformation to find integrations of some functions. So very complex functions. Remember, it's not possible to do it in hand, or it's not possible to use some available functions that what we have. But Fourier transformation has done this job little easier. Of course, there's some work is there, but the work is worth to do it to find out the integration of this. All right, guys. Thank you for the listening, and I'll see you in the next lecture with more problems. Thank you, guys.